Have you ever looked at a picture of a Brachiosaurus or an Argentinosaurus and just thought, how did these creatures get so unbelievably massive? It's a question that has baffled paleontologists for decades. These sauropods, the long-necked, long-tailed giants of the Mesozoic era, weren't just big. They were titans, the largest land animals to ever walk the earth. Some stretched over 130 feet long and weighed more than a whole fleet of modern-day elephants. So, what was their secret? Was it something in the air? Something in the water? Well, the answer is a fascinating mix of evolutionary brilliance, a changing planet, and a whole lot of evil. To really understand their secret, we need to travel back in time. Not just to any time, but to the Jurassic period, around 200 million years ago. Picture a world vastly different from our own. The continents are clumped together in the supercontinent Pangaea, which is slowly starting to break apart. The climate is warm, humid, and stable, with much higher levels of carbon dioxide in the atmosphere than we have today. This CO2 acted like a super fertilizer for plant life. And this is where the story of Sauropod Gigantism truly begins. The Jurassic world was a lush, green place. Forget the grassy fields you see today. Grasses hadn't evolved yet. Instead, the landscape was dominated by vast forests of giant plants. We're talking about towering conifers, cycads that looked like chunky palm trees, and endless carpets of ferns. This was an all-you-can-eat buffet for a hungry herbivore. The sheer abundance of food was the first crucial ingredient for growing big. There was simply no shortage of calories. If you wanted to become a giant, the resources were right there for the taking. But just having a lot of food isn't enough. You need the right equipment to process it. And this is where the sauropod's unique anatomy comes into play. Let's start with that incredibly long neck. For a long time, scientists debated whether they held their necks high like giraffes or low to the ground. The current thinking is that they did a bit of both. That long neck was like a giant feeding boom. It allowed them to stand in one spot and sweep their heads across a massive area, munching on low-lying ferns, mid-level cycads, and even reaching high into the coniferous canopy. This was incredibly energy efficient. Instead of wasting precious calories trekking from one bush to another like a modern elephant, a sauropod could park itself and just graze, and graze, and graze, saving energy that could then be channeled into growth. Now, let's talk about their heads. Sauropod heads were ridiculously small compared to their bodies, and their teeth weren't for chewing. They were simple, peg-like teeth, designed for one thing: stripping leaves from branches. They'd just rake in mouthfuls of foliage and swallow it whole. Chewing takes time and energy, and it requires heavy, complex skull muscles. By skipping the chewing part, sauropods could keep their heads light, which in turn allowed their necks to grow even longer without becoming too heavy to support. It was a brilliant evolutionary trade-off. But if they weren't chewing, how did they digest all that tough plant material? The answer lies in their massive gut. Sauropods were basically walking fermentation vats. They had enormous torsos to house a vast digestive system. Once they swallowed the plant matter, it would travel down to their gut, where it would sit and stew for days, broken down by a cocktail of gut bacteria, and gastroliths are stones that the dinosaurs would swallow. These stones would churn around in their stomach, grinding up the food that their teeth couldn't handle. It was an internal food processor, working 24/7 to extract every last nutrient from the tough vegetation. This super-efficient digestive system was another key pillar supporting their immense size. Another piece of the puzzle is their breathing. How do you get enough oxygen to power a 70-ton body? Sauropods evolved a respiratory system remarkably similar to that of modern birds. They had a complex system of air sacs connected to their lungs. This didn't just help them breathe, it made their skeletons lighter. Their vertebrae were not solid bone. They were filled with these air sacs, creating a structure that was both incredibly strong and surprisingly lightweight for its size. Think of it like the internal trusses of a bridge. This pneumatic skeleton, as it's called, solved a huge biomechanical problem: how to support a massive frame without collapsing under its own weight. It also meant They had a one-way flow of air through their lungs, a far more efficient way of extracting oxygen than our own in and out mammalian system. More oxygen meant a higher metabolism and more energy for growth. Growth itself was another of their superpowers. Fossil evidence from baby sauropods shows that they grew at an astonishing rate. They hatched from relatively small eggs, maybe the size of a soccer ball, and then just exploded in size. They would pack on pounds every single day, reaching near adult size in just a couple of decades. This get big fast strategy was likely a defense mechanism. In a world full of fearsome predators like Allosaurus, the best way to avoid being eaten was to quickly outgrow anything that might want to eat you. Once a sauropod reached its full size, it was virtually untouchable. It was the ultimate apex herbivore. And let's not forget their metabolism. For a long time, it was assumed that as reptiles, they must have been cold-blooded. But it's hard to imagine a cold-blooded animal getting that big and growing that fast. The current consensus is that they were likely their sheer bulk meant they would lose heat very slowly. Their bodies would act like giant thermal batteries, maintaining a high and stable internal temperature simply because of their size. This would have given them a higher metabolic rate than a typical reptile, allowing them to stay active and fuel their rapid growth, without needing the super high metabolism of a warm-blooded mammal, which would have required them to eat even more food than they already did. So, the secret to Sauropod gigantism isn't one single thing. It's a perfect storm of conditions and adaptations. You start with a warm CO2-rich planet that produces an endless supply of plant food. Then, you evolve a super long neck to efficiently harvest that food without moving. You develop a lightweight head with simple teeth for raking, not chewing, allowing that neck to grow even longer. You swallow your food whole and let a massive gut, filled with grinding stones and bacteria, do the hard work of digestion. You evolve a bird-like respiratory system with air sacs that not only provide abundant oxygen but also lighten your skeleton, making it both strong and light. You grow at an incredible rate to escape predators. And finally, your enormous size helps you maintain a stable body temperature, powering the whole incredible system. It was a unique and unrepeatable experiment in the history of life. When the world changed, when the climate cooled and the types of plants shifted, the age of the sauropod giants came to an end. They were so perfectly adapted to their specific Jurassic world that they couldn't survive outside of it. Their story is a powerful reminder of how life can push the boundaries of what's possible, creating creatures more wondrous than anything we could ever imagine. They weren't just big, they were a masterpiece of evolutionary engineering. Thanks for watching and exploring the world of these magnificent giants with me today. If you enjoyed this journey back in time, don't forget to hit that like button and subscribe for more deep dives into the mysteries of the ancient world. See you next time.